Welcome to The Explainer. Today, we're going to dive into a really cool concept in machine learning, how an algorithm literally learns to see the hidden patterns in data just by figuring out its shape.
So, let's kick things off with a big question, one that's at the heart of everything from your spam filter to your bank's fraud detection. To spot something weird, a machine first has to learn what normal even looks like. But how on earth does it do that?
Well, the answer, and this is pretty cool, starts with a surprisingly simple idea. It has to understand the shape of the data. Yeah, that's right. Just like a landscape has hills and valleys, a set of data has its own unique form that tells a story.
Okay, so to get a real feel for this, let's grab an example straight from the source material. Picture this. We've got the weights of 18 people. Right now, it's just a boring list of numbers.
Now, what happens if we just throw each of those weights onto a chart? You get this mess. Seriously, take a look. Can you tell what a typical weight is here? It's pretty much impossible. It's just a bunch of random spikes.
But here's the crazy part. Hidden inside all of that chaos is a really clear story about the group as a whole. We just need the right tool to pull that signal out of all the noise.
What we really want to find is this, a nice, smooth curve that shows the true distribution of weights. This shape tells you everything, instantly. Where the curve is high, that's a common weight. Where it's low and flat, that's a rare one. See? That's the story we're trying to find.
So, this whole process, right? Going from that mess of individual points to this beautiful, meaningful curve, it has a name, and it's called density estimation. It's basically the statistical magic trick for finding the hidden shape in your data.
Okay, so that's the what. But what about the how? How does a machine actually connect those scattered dots and figure out what the underlying shape is?
Well, the main trick up its sleeve, as the source material points out, is this really clever idea called kernel density estimation. You might also hear it called parse in Windows, but it's the same thing.
And you know what? The process is actually super simple. First, you've got your scattered data points, right? Then, for every single point, you drop a little smoothing bump right on top of it. It's called a kernel. Think of it as giving each data point a little bit of influence on the area around it. Step 3, you just add up all of those little bumps, and voila! What you're left with is that final smooth curve we've been looking for.
And this quote from the source material just nails it. The real challenge is, how do we transform this raw data into a realistic estimate of the density? That's the whole game right there.
Now, you might be thinking this all sounds like a neat party trick, but it's not. This whole thing is built on some really solid, powerful statistical principles that give us the confidence to actually trust the results.
First up, we've got the big one, the law of large numbers. All this really says is that the more data you have, the better your estimate gets. The more weights you measure, the more emails you analyze, your estimated shape just gets closer and closer to the real thing. It's that simple. More data equals more confidence.
Statisticians also have this awesome recipe book for common data shapes, and it's known as exponential families. This includes all the classics, like the famous bell curve, the Gaussian distribution. These are basically pre-made templates that help us make sense of these patterns once we find them.
Okay, great. So we can find the shape of data. So what? Who cares? What can a machine actually do with this knowledge?
And this, right here, is the crucial point. Once an algorithm truly understands the shape of normal, it unlocks the ability to make some incredibly smart judgments about brand new stuff it has never ever seen before.
This opens up two massive capabilities. First, classification. An AI can learn what the shape of a spam email looks like and what the shape of a legit email looks like. Then, a new email comes in, and it just asks, which shape does this one fit better? Bam, sorted. But second, and this is a real game changer, is anomaly detection. Your bank learns the shape of your normal spending. Then a weird charge pops up, way out in the flatlands of that graph. The system immediately flags it as potentially fraudulent. That's how it works.
And that, right there, is the magic. Density estimation isn't just some abstract idea from a stats textbook. It's an incredibly practical tool. It's how we teach a machine to see patterns, to tell the difference between what's ordinary and what's extraordinary. So this leaves us with a pretty mind-bending thought to chew on. We've used this to understand things like human weights, spam emails, and credit card purchases. But just imagine, as we start feeding machines way more complex data from science, from society, from the universe, what other, deeper, hidden patterns are they about to show us? What shapes are out there that we've never even seen before?